version. Any version's fine. So I'm just going to grab whatever the latest is. And then in the documentation, it's going to show us that we have to pass in some environment variables. And so you can see here, looks like, where is it? It's going to be somewhere down here. Here we go. So these are the two variables, the environment variables that we have to pass in to make sure our Mongo container works properly. So we have to provide the root username and the root password. So I'm going to copy these. And feel free to set it to whatever you want. I'm just going to call this Sanjeev. And then let's grab the password as well. And I'm just going to say my password. So let's save this. And then let's do a Docker compose up. We don't need to do a -- build. All right, so now we can see that it is now creating our Mongo container. And if I do a Docker PS, we should now see two containers. We have our Node Docker Mongo container as well as our Node app as well. So now that we have our Mongo container up and running, what I want to do is I want to connect into the container and just poke around a bit. So let's do a Docker exec -it, and then the name of the container. And then we'll do bash. So we can take a look at the file system. And so here, since we're connected to the container, we can actually connect into Mongo. So if I type in Mongo, and then we got to pass in a couple of flags. That's going to be for your user and password. So if I do -u, you pass in your username. And so that's going to come from that environment variable that you set. And then we have to pass in -p for the password. And so now we're logged into our Mongo instance. And I want to run just a couple of Mongo commands. If we type in db, this is going to show us what database we're connected to. And so right now we're connected into a test database. I guess Mongo creates a test database so that we have some database to log into. And we can create a brand new database with the use command. So if I type in use and then the name of my new database, so I'm just going to call this mydb. You can see that it's switched to our newly created database. And we can run the command show dbs to list all the databases. And you can see that mydb is not listed on here. And that's just because Mongo won't list this database until we have a document or an entry within that database. And that would probably explain why we don't see test in that list as well. So let's create an entry. And let's just say we're making like an application, like a library type application that's going to store a list of books. So we can do db, then the name of the collection, which is called books. And then we'll just do an insert. So here we have to pass in the properties of that entry. So we'll say name is going to be Harry Potter. All right, and so this means we successfully wrote to our database. And if I type in db.books.find, this is going to list out all of the documents within our books collection. So here we've got one entry, and we can see the name is set to Harry Potter. Perfect. And if we do a show DBs now, we can see my DB is now listed on there. So let me log out of here. And let me log out of here. And I do want to show you guys one thing real quick. So if you remember, if your goal is to get into the Mongo shell or the Mongo CLI, instead of having to do a Docker exec it and then bash and then run, where is this command? Mongo-u. Instead, what we can do is we can skip the bash and just run mongo-u, then the username, and then the password. All right, so just a quicker way to get there. But now what I want to do is I want to tear down our container. So let's do a Docker compose down. And I'm going to use the -v like we've been doing to make sure that we delete that anonymous volume. And then I want to bring it up. And I know you're thinking like, well, why did we tear it down just to bring it back up? It's obviously so I can teach you guys something. So let's do up -d. And let's give it a few seconds to fully boot up. And then what I want to do is I'm going to log back into the Mongo shell. And let's do a show DBs, right? And right there, something looks odd, right? Our database that we created called MyDB is now gone. And you might be wondering, well, what exactly happened? Well, think about it. We had a container, our Mongo container. We ran a Docker Compose down, which then deletes the container. Then we ran a Docker Compose up, which then creates a brand new container. So this is a brand new container. Everything that was in the previous container has been deleted. And this is a major problem because this is our database. We don't want to lose that information. I mean, if you're doing, running like node tests and things like that, then yeah, maybe you'd want your database to kind of start from a fresh state each time. But, in a production environment and even in a development environment, we want to keep all of our database information so that we don't have to keep recreating those entries. And especially in a production environment, if you lost your database, that's all of your application data that's just gone, right? At that point, you've pretty much broken your website or whatever application you're building. So you don't ever want to lose that information. And so how do we actually save that information? And I'm sure you guys already know this, right? We use volumes. If you look at our Docker Compose file, actually, let's go to the dev file. And for our node app, you remember there's two different volumes here. So this helps us persist data. So let's do the same thing with our Mongo container. So let me exit out of here. And let's do a Docker Compose down. And let's go to docker-compose.yaml. And let's add some volumes. And, if we go back to the dev, actually, to the .dev YAML, you'll see that there's two different volumes that we covered. We covered the bind mount, which syncs the data within the container to a folder on your local drive. And then we have an anonymous volume. So, we could theoretically use either one. If you wanted to be able to poke around on your database data on your local machine, then you'd use a bind mount. But however, I don't really care about looking at that data. I can just log into the Mongo client and actually just run commands to see what I need. I don't care about the file system. So it looks like anonymous volume is a better choice. However, here's the problem. If you have an anonymous volume, and I think I have a few left. So if I do Docker volume ls, right? These are what anonymous volumes are, right? Just a bunch of random numbers, just a random string or ID. I have no idea what these are for. And so when you have an anonymous volume, there's a good chance that you may accidentally delete it. And so I don't feel comfortable using an anonymous volume for this scenario because this is our application data, right? I want to make sure I know which volume is storing that data. So what we can do is we can create a named volume. Named volume is exactly the same as an anonymous volume, except we can give it a human readable name. So let me show you guys how to do that. And let's go under our Mongo service. And let's create a volume. And so here, just like an anonymous volume, we have to pass in a path within our container. And so to get that information, we have to look at the docs. And let's take a look. So here we go. It's probably under this where to store data. And so you can see they created a volume. And here they used a bind mount, so they stored it on their local directory, and they synced it with /data/db. So this is the folder in the container that we're interested in. So we want to do /data/db, and at this point, this is an anonymous volume. To convert this to a named volume, all we have to do is just do a colon, and then just give it a name. So I'm going to call this mongo-db. So it's going to save this volume with the name of mongo-db. Right, and just to show you the difference, right? A bind mount, you provide a path on your local machine to a path on the container. An anonymous volume, you just provide a path to the container directory that you're interested in. And then for a named volume, you do a name, colon, and then the path within the container. But there's one more gotcha. Actually, let's save this and I'll show you what happens if we try to run this as is. So let's do a Docker Compose up. Right, and it says, named volume is used in a service Mongo, but no declaration was found in the volume section. Right, so it's saying that we have to declare something. And when it comes to named volumes, we do have to declare this volume in another portion of our compose, in our Docker Compose file. And that's because a named volume can be used by multiple services. So, if we had a, like another Mongo instance or another Mongo service or any other service, they can attach to the same exact volume just like this Mongo service does. So all we have to do is at the bottom, we just provide volumes. And so here we just provide a list of all of our named volumes. So here we just call this mongo-db. That's all you have to do. Now let's do a Docker compose up. And let's connect into our Mongo client. Right. Remember, everything's gone. So let's create a new database and let's just insert that same exact entry. All right, perfect. So now let's exit out of here and let's tear down our all of our containers with a Docker compose down, and let's bring it back up and let's just verify that our information saved. So let's do a Docker compose down. Now this is where we run into another issue, and that's why I wanted to show you guys this. So remember, we're using this -v volume, this -v flag, to automatically delete this anonymous volume. Because we don't need it. It's just there for that one little workaround for our Node application. However, the problem is that this will delete not only anonymous volumes, but also named volumes. So if we pass in this -v flag, it's going to also delete this database, our Mongo database volume. And so we obviously don't want to do that because we just went through all of this hassle so that we could save our database data. So we unfortunately cannot use the -v flag anymore. So what you're going to have to do is remove the -v flag, and just do it down. And after that finishes running, if you do a Docker volume ls, this is going to list out all of your volumes. You can see we have our node Docker MongoDB volume. So you can see it's given a nice name. So we know exactly what this is being used for. But we've got all of these anonymous volumes. So you'll see over time they start to build up. And you just have to delete them yourselves. And so there's a nice easy command called Docker volume, I believe, prune. But don't run it yet. Instead, what I recommend that you do is start up your containers. So bring this back up. And then do a Docker volume. And then do a --help. And so we have this prune command, which removes all unused local volumes. So all of the volumes that are being used right now by the running containers will not get deleted when we run the prune, only the ones we don't need. So as long as you start up your application, then your MongoDB and then whatever anonymous volume is associated with your application at the moment will not get deleted, and we can just clean up all the rest of the data that we don't care about. So if I do a Docker volume prune, we should be good to go. And so now if I do a Docker volume ls, you'll see we've got significantly fewer volumes. These are just the ones being used by either running or stopped containers. So just make sure you, I believe you should start your containers, but I could be wrong. Maybe it also saves stopped containers as well. So you might want to double check on that within the documentation. But I do want to highlight, just make sure that you only delete stuff that you don't need. All right, so now let's do a Docker PS. We have our Mongo container, and let's connect into that container again. And let's just do show DBs, and we can see that our data is still there. And if I do a db.books.find, oh, I forgot to switch databases, so we have to use MyDB. And then now we do this, and there we go. So we've now got persistent data for our Mongo database. So now that our Mongo database is up and running, let's set up our Express application to connect to our Mongo database. And when it comes to interacting with our Mongo database, we're going to use a library called Mongo. So it's going to make it a little bit easier to talk to our Mongo database. And so here, if we pull up the documentation for Mongoose, we can see To install it, we just do npm install mongoose. So let's do that right now. All right, and so once that's done, first of all, we installed a new package. So we have to tear everything down. Remember, no more -v because we have our database. So let's do down. And then let's do an up again. And we want a -- build. All right, and now going back to the documentation, the first thing we have to do is we have to import mongoose. So let's copy that line. We'll paste that in there. And then we have to connect to our database. So here we just call the mongoose.connect method. And then we have to pass in our URL as well as some config options. And so the full URL, if you pull up the actual mongoose documentation, it's going to look something like this. We do mongodb, and then :// then your username, your password, the IP address of the host, the port, and then some options as well. So under here, we'll do mongoose.connect, mongodb, // and then here, you pass in your username. So mine's Sanjeev, and then the password's going to be my password, and then here we have to give the IP address. Right. And so this is probably where most of you guys are going to get stuck, because we have to figure out, what is our IP address? How does IP addressing work with Docker containers? Well, here's the thing. Docker makes it really easy to work with containers, and it automatically assigns your containers an IP address. So if you ever want to figure out what the IP address of a container is, first of all, do a Docker PS, get all your Docker containers that are running. And then here you can do a Docker network, Docker inspect. So this is going to give us more detailed information about a container, and we can grab our container name. So here I'm just going to grab our Node app first, just to take a look. And so here you're going to get a ton of information. And if we go all the way to the top, let's take a look at what's up there. A lot of random information that we don't really care about. And I believe what we're interested in is going to be all the way at the bottom. So let's scroll on down to the bottom. And here there's a section called network settings. So this is probably where we want to look. And so if we keep going down, you can see there's something called networks. And so there's a concept within Docker called networks, where you can create more than one network and then put different containers within those networks, so that only the containers within a network can talk to one another and they can't talk to containers in other networks. So it looks like there's a container called node docker_default. So, this represents our directory name. So this looks like it was created by Docker Compose, and it actually was. So Docker Compose does create a brand new network just for your application, so that all of the containers and services within your Docker Compose file will get placed into that network. And you'll see here, we have an IP address. So this is the IP address of our Node application. And then here you can see its default gateway. And so we want to grab the IP address of our Mongo container. So let's do the same thing for our Mongo container. And let's do a Docker inspect and then grab the name of our Mongo container. Once again, it's using that same exact network that was created. And we can see here, this is the 172.25.0.2. So this is the IP address. And I'm just going to copy that. We can paste it in here. And then we want to put the port that's going to run on, that Mongo's running on. So it's going to be running on the default port, as long as you didn't change any of the default configs. So 27017. And then we're going to pass this one property auth source equals admin. All right, let's save that. And then here we're going to call .then. So here we're going to pass in an error function, and we're just going to say, if we successfully connect to our database, I just want to do a console.log, and we'll just say successfully connected to database. And if this failed, we'll just do a .catch, and we'll say, first of all, we'll pass in the error, and we'll just console.log error. All right, let's save that, and let's see what happens. So if we do a Docker PS, and then we're going to do a Docker logs, And we'll connect to that node application. So here we can see that it said successfully connected to database. So it looks like we've successfully connected to the database and everything's working. However, there's something I don't like, right? Right now, we had to go into Docker inspect to get the IP address of our container and then put it into our code. However, if we stop and start our containers, or if we do a Docker compose down and then back up, right? First of all, there's no guarantee that we get the same IP address. And even if we could guarantee the same exact IP address, the first time we run it, we'd have to go in, we'd have to get the IP address and then update our code. And that's just a really sloppy way of doing things. And so Docker actually has a nice feature that allows us to make it easy to talk between containers, right? And this feature only exists when it comes to custom networks that get created. So if I do a Docker network ls, you'll see there's a couple of networks that we have. We've got the bridge and host network. So these are the two default networks that come bundled with Docker. And then I've got a couple other ones. You may not have these, but you'll see that we have one for our node Docker default. So this is the one Docker Compose created. This is the custom one that created just for our application. And when you have a custom network, this only happens with the custom networks, the ones that you create, and not one of the two default ones. When you have a custom network, we have DNS. So when one Docker container wants to talk to another Docker container, we can use the name of that container or the name of that service to talk to that container. And so if we go back to our docker-compose file, you'll see that the service for my node app is called node app, and the service for my Mongo container is called Mongo. So I can refer to this container's IP address based off of this service name. So if I call Mongo within my node app, it's going to automatically grab the IP address of our Mongo container. So if I go back to our index.js, I can change this to Mongo. And then here, if we do a Docker logs, and let me just do a pass in a -f. I think it's -f for follow. Actually, let me just do a help real quick. Yeah, -f follow. And then here, if I save this, you can see we still successfully connected to the database. So because of DNS, we're able to resolve this name, this host name, to be whatever our Mongo container is. And just to show you guys exactly how that works, let's actually log into my node application container. So if I do docker exec, actually first of all, do docker ps, and we'll do docker exec -it. And then here we'll drop into bash. Let's ping Mongo. Let's see what happens. Look at that, right? It automatically uses DNS to resolve the name of Mongo, and it got the IP address of 172.25.0.2, which is our Mongo container. So that's how this whole DNS process works. So anytime you want one of your containers to talk to another container, all you have to do is refer to its service name, and it'll automatically be able to resolve it because DNS is built into Docker. And keep in mind, this is only applicable to networks that you create. It does not work with the default bridged network, okay? And if you want to take a look at your networks, we can actually do a Docker, first of all, we'll do a network ls, and we can do a Docker network inspect. Well, first of all, I have to grab the specific network I want. So the one that's specifically my Docker Compose created, and then we can do inspect. And I messed up the order. Sorry about that. It's going to give us some more information about this specific network. So you can see here the subnet that all of our containers are going to use the 172.25/16. We can see what the default gateway is. And then we can see under the container section all of the containers we have. So we've got our Mongo container, and we can see the IP address as well as the MAC address of this container. And then we can also see the container for our node application. And so this has also got an IP address and a MAC address. And I believe, and don't quote me on this, but it looks like, yeah, actually that's all I wanted to show you guys from here. So I think that's going to wrap up this network section. So in the next section, we're going to make a few changes to our application so that it's a little bit easier to work with environment variables, and we can kind of store them all in this same area and section. All right, so one thing I don't like in our application is that, first of all, we're hard coding the URL into our application. You never want to do that. Instead, what I would rather do is have this URL stored as an environment variable. And so that way, when we move to production, there's nothing that we would need to change. We can just pull the environment variables that we set either in Docker Compose or on the host machine. So what I want to do is within our base directory, I'm going to create a new folder. And I'm going to call this config. And within here, I'm going to create a new file called config.js. So this is going to store basically a variable that holds all of our environment variables. And so here I'm just going to do a module.exports equals. And then here I'm going to store all of our environment variables. So if we go back to our URL, there's a couple of things we need to pull out of here. We need the username for our Mongo database, the password. We also need the IP address. We know with Docker, we can always use Mongo. So, whether you're in development or environment for the IP address, you can always use Mongo. So technically, we don't even need to save that as an environment variable. But, down the road, you definitely want to think about the future. There may be a time where you decide that, what, I don't want to keep my database as a Docker container. Maybe you want to use some kind of managed service. So in that case, we can no longer use DNS because it's no longer going to be running as a container. So if you ever do decide to maybe move your Mongo database to outside of the Docker world and then have it hosted by AWS or some other hosting platform or cloud platform, then you would need to pass in the IP address as an environment variable. So I like to just store everything as environment variables just so that we can plan for the future. So we need those three. And the port, because who knows, right? The port could change in the future. So let's go back to our config.js, and I'm going to define a property called mongo_IP. And then here, this is going to grab process.env.mongo_IP. So we're going to make sure that our Docker containers pass this environment variable in. However, if it's not set, then we're going to default to Mongo, right? So that's what the double pipes mean. So if this is set, then we're going to use this value, and Mongo IP is going to be stored to the value of this environment variable. However, if this is not set, then this variable is going to be set to Mongo, right? And so the reason I'm doing that is because we can always default to Mongo as our IP if we don't pass anything in. The next thing that I want to do is we'll grab the Mongo port. So I'll call this Mongo_port, and we'll say process.env.mongo_port. And then here, we're going to pass in the default value of 27017. Then we want the Mongo user. And we'll pass in the value of the environment variable of Mongo_user. And we don't need to default that. And then we need Mongo password. All right, so now just make sure that we're exporting it. And what I'm going to do is in our index.js file, we can then import those environment variables. So here, this is what I'm going to do is I'm going to change this to the template string, and then we can then grab those values. So here, this is going to be the username. So we'll just say Dalin, and then we're going to grab in Mongo_user, right? And then make sure we let VS Code import it or manually do it yourself. Then the password, we want to do the same thing. Right. Then here we also want to pass in the IP address. And then grab the port as well. Right. And make sure to let VS Code import all of these for you. And that should be about it. Technically, we could do the same thing right here for port. I just like to kind of have a config file right here that holds all of my environment variables so I can know exactly where to look if I ever need to change anything. And it's just kind of nice to have all of these in a central location. But this section, this part of the video, completely optional. All right, let's save all. And then let's, so now that we saved it, let's go do a Docker logs. And it looks like we got an error. So what happened here? It looks like we got an authentication failed. So we clearly messed something up. Let's just make sure we save this. And right, it's failing because, well, first of all, we haven't passed in any of these environment variables. So we don't have a user or a password right now. So we have to pass that into Docker Compose. Okay, and so here right now we've been using the base Docker Compose file for everything. And that's just because I just wanted to start off with something simple. But I think it's time we started kind of splitting things up between our dev and prod for Mongo. So right now we're just working on our dev environment. So let's copy all of the Mongo related stuff that's for our dev environment and move it into the dev.yaml so that we're not cluttering up the shared configs. So for the environment variables, let's copy those. Actually, I can copy all of this for now and go into our dev. And then here, we can remove image because that's not going to change whether it's production or development. We'll set these environment variables. And then we also need to set the new ones as well. So what is this? Mongo underscore user. This is going to equal same thing as this in this case. And actually, I'm making a mistake. So this is going to go under our node app, right? This is an environment variable for our node application. We'll set that to Sanjeev. And then here we'll set this Mongo password equal to my password. And that's all we should need because the rest can default to what we're already using. So we don't need to pass those in. And then now I think we should still be tailing this. And we actually have to rebuild the containers because we passed the new environment variables. So let's stop this. And we're going to have to do a Docker Compose down. And let's bring it back up. And I realized it connected to the wrong container. We want our node application. All right, perfect. So now we can see we've successfully connected to the database. And once again, guys, this part of the video was purely optional, but I just kind of like having everything in a centralized location. And I just want to make sure that we kind of think about what our application is going to look like in the future and make sure that we can handle making any changes to where our Mongo database is actually stored. All right, if we take a look at the logs right here, you'll notice that we've got a couple of warning messages. So to clean up these Mongo warning messages, as well as maybe kind of clean up our index.js file, what I'm going to do is I'm going to actually store our URL into a variable. And so here I'm going to do const, and then we'll call this Mongo URL. And I'm just going to store this URL up here. And then in the connect method, I can just call Mongo URL. Then to get rid of those warning messages, I'm going to pass in a few properties. Don't worry too much about these. It's not really going to affect the functionality of our application. It's just going to make sure that we don't see those annoying warnings. All right, and so that's all the changes I wanted to make in this case. I just wanted to clean it up just a little bit. So let's save that. Let's make sure that we've successfully connected and we should be good to go. Now, when it comes to starting up our Docker containers, especially using Docker Compose, we can run into some potential issues. And that is when we spin up both our node container as well as our Mongo container, we don't actually know the exact order that these will get spun up on, right? Docker is just going to bring them up at the same time or relatively close to the same time. And that can lead to issues because if our node container spins up first, it's going to run this code right here to try and connect to our database. However, if our database is not up, it's going to throw an error and then crash our application. So we need a way to kind of tell Docker to load up our Mongo instance, our Mongo container first, so that we can ensure that when it's up and running, only then does our node container connect to it. And Docker Compose has a depends on field that we can use. So if we go into our docker compose.yaml, we'll use the shared one in this case because we would want the same behavior, whether it's in our production or our development environment. And under our node app service, we'll say depends _on. And then we have to pass in the name of the service that we depend on. So we'll do slash or dash, and then the name of the service. So in this case, Mongo. And so what this is saying is that because our node app service depends on Mongo, we are going to start our Mongo container first. All right, so that kind of helps us. So let's tear everything down. And then let's bring everything back up. All right, now we can see that our Mongo container was started first and our node app was started second. And keep in mind, if you run this, enough times, you can confirm that it's always going to be the Mongo container first because it sees that our node app is dependent on our Mongo service. However, this still does not technically fix our issue because the only thing Docker does is it spins up this container first. It has no idea whether Mongo has fully initialized. It has no idea if the Mongo database is actually up and running. It just spins up the container. Right? It doesn't do any checks to verify that our Mongo database is up and listening for connections. So despite the fact that we have depends on, it doesn't necessarily solve our issue. It helps a little bit, but once again, our application, we could end up catching it where the Mongo container is up and running, but Mongo itself is still down and hasn't initialized, and our node app is ready to connect to it, right? And then at that point, our application crashes. And so ultimately, there's nothing Docker can really do in this case, or nothing specifically that Docker Compose can do. Maybe if you have an orchestrator, you can kind of work something out. But at the end of the day, you shouldn't rely on Docker or your orchestrator to handle that. Instead, you want to implement some sort of logic in your application to handle this scenario where your Mongo database isn't up and running before your application starts. And so usually that involves, if you try and connect and you're unable to connect to it, you want to keep retrying until you're able to successfully connect to it. Now, Mongoose in this case will actually try for 30 seconds automatically for you. After 30 seconds, you'll crash out. But for 30 seconds, it will just keep trying and trying and trying. And that's what we want. So it's great that Mongoose has this out of the box, but I just want to make sure that you guys understand that ultimately you need to implement some sort of logic in your applications to ensure that you can handle this scenario. And I'm going to show you as an example of something that you could do. And I'm not saying this is best practice. It most certainly is not. It's probably not the best way to handle this, but I just want to show you how we could somehow implement some sort of logic in our application to keep retrying until Mongo is up and running. So let's go back to our index.js. And what I'm going to do is I'm going to create a function. And I'm going to call this connect with retry. And I'm going to take this mongoose method right here. I'm going to drag it right into my function. And then under the catch section right here, I'm going to remove this. First of all, actually, I'll keep the console.log. I don't know why I removed that. But then if we error out for whatever reason, ideally we should check to see if it's because we could not connect to the server, but let's just assume because it's trying to connect that any error we get is because we couldn't connect to it. We'll say set timeout, and then we'll call this same exact function. So we'll do connect with retry, and then we'll just say after 5 seconds. So what's going to happen is we're going to call this function when we start our application, and then it's going to run. It's going to try and connect. And if we can't connect to it, what we'll do is we'll wait 5 seconds. So that's the purpose of the set timeout. We'll wait 5 seconds, and then we'll just call connect with retry. So we'll just call this function again, and then we'll try and connect. And then we'll do the same thing. We'll wait 5 seconds and just keep trying this. So this is going to loop forever until we can finally hit this then statement, right? Which is when we successfully connect to it, and then we can break out of this function. So that's just an example of how you would implement something within your application. I'm not saying it's best practice. I'm sure there's there's some negative aspect as to the way I've implemented this, and maybe it's not best practice. I'm just here to try and kind of sell home the point that you need to make sure your application handles the logic. Don't rely on an orchestrator. Don't rely on Docker or Docker Compose, because none of them can truly guarantee you that your Mongo database is fully up and running before your application starts. Make sure your application is intelligent enough to handle that scenario. And so the last thing that we got to do is we got to call that function. So here we just do connect with retry. Let's save that. And now to actually test this out, first of all, let's do a Docker. First of all, let's tear everything down. And now I'm going to show you a command that we have, or an option that we have with our Docker Compose up. So if we run up again with the -v, if we just run this like this, it's going to start all of our containers, all of our services. However, we can tell Docker Compose to only start up specific services. So in this case, we would want to bring up our just our node application. So if I do a --help, you can see at the top, we can just provide our service names. Where is it? I think it's somewhere here. It's listed somewhere here if you check it, but it'll list out, you can specify just the services you want to start. So if I do, and first of all, that shouldn't be -v, that should be -d, sorry. So here I can type in node-app, right? And so that's just coming from our service name. And so this should start just our node application. So if I hit that, we see a little bit of an issue, right? It started our Mongo container. So why exactly did it start our Mongo container? Well, that ultimately comes down to the fact that we use this depends on flag. So because this service depends on Mongo, right, it's going to start Mongo no matter what. So let's tear this back down, and I'll show you how we can start just our node application. Now here we do up -d and then node-app. And let's do a --help. And let me do that before the name of our service. So here. And there should be a specific flag, and that is no deps right here. So that says don't start linked services, or it's basically saying you don't need to start the dependencies. So when we start up our node application, despite the fact that we depend on Mongo, it will not start up any of our dependencies. So that's the exact flag that we want. So let's hit an up arrow, remove that, and then the --. I already forgot what it was. No deps. And then we want to call our service name, which is node-app. All right, so now it's going to start just our node application. We do a Docker PS just to confirm. Perfect. And then let's do a Docker logs. And then we'll call this. And then -f. So let's take a look at our application and let's see what happens. And I can't remember if I did a save all. I mean, let's just do a save. There we go. Okay, so we can see that Mongo tried to connect, right? And it said connection timed out. All right. And so, by default, I think Mongo waits like 30 seconds again afterwards or something like that. So let's see if my for loop, actually it wasn't a for loop, but if my repeating function works. So we should ideally see the same exact error message when it tries to reconnect in a few seconds. And there we go. So I don't know if you guys saw that flash before you, but it spitted out the error once again. So this confirms that my application is continuously trying to connect to Mongo. So let's bring up our Mongo container now. So we can do a Docker Compose up. And then here, we can remove all of these flags and just bring up our Mongo service. And so now if I run the Docker logs again for our node application, when it tries to retry, once again, it should then successfully connect. And there we go. So now we can see that we've successfully connected. And this confirms that our Node application is intelligent enough to handle a scenario where our Mongo database is not up and running at a specific moment in time. So it will just continuously retry over and over and over and over again until the database is finally up and running. So now that our Node application can successfully talk to our MongoDB instance, I think it's time we started to build out a demo CRUD application. And I was trying to think of what would be the best example project, and I realized that searching through YouTube, I could not find a single tutorial that covered how to build a to-do application. So that's exactly what we're going to build. Nah, I'm just kidding. I would never build the most annoying application. Instead, what I'm going to do is I'm going to build the second most annoying application, which is a blog application. So let's get started. Now, keep in mind, when we start building out the Express side of things, I'm going to move a little bit quickly just because I want to make sure this video focuses more on the Docker side of things. I'm going to expect you guys to have a little bit of background when it comes to Express already. So I'll move quickly. If you have trouble keeping up, I would recommend watching another tutorial on how Express works and then coming back to this. But I want to make sure that anybody watching this, whether they're interested in Express or Node, that they can follow along, because the idea behind all of this is all about the Docker side of things and how we can build a development to production workflow. So let's start off by creating a couple of folders. So the first folder we need is one for our models. This is going to store our Mongoose models. We'll create a new folder for our controllers as well. And we'll create a new folder for our routes. And so let's start off by building our models. And I'm going to create a new file, and we'll call this our post model. So this is a blog application, so we need something to represent our blog posts. And from here, we want to import Mongoose. And we'll do const post schema. And here, let's think about the properties we want to give it. So it's got to have a title. And we'll say this is going to be a type of string. And then we're going to say this is required. And we'll set that to be true. And if they don't include a title, we'll throw an error and say post must have title. The next property you should have would be a body. So this is going to be the content of the post. So once again, this is going to be a type of string. And we'll say required as well. And we'll say post must have body. All right, so this is going to be our blog model. Fairly straightforward. And then here, let's just make sure we export it. And now let's create our controllers so that we can handle creating, reading, updating, and deleting our posts. We'll call this post controller. And so first thing we want to do is we want to import our post model so that we can actually, interact with our database and create posts. And then we'll do export, and then we'll define our controller for retrieving all posts. So we'll do get all posts. And this is going to have a request, response, and next as well, although that's optional for a route. All right, and the way to retrieve all posts with Mongoose is we can just say const posts equals post.find. So that's going to connect to our database and retrieve all of our posts based off of this model. However, there's a couple of things we have to do. First of all, this is an asynchronous method, so we have to